Welcome back everybody. In this session we will discuss about second type of SJF scheduling, that is called as preemptive SJF scheduling. One more name is there for this, that is shortest remaining time first scheduling. So in the last video we have already discussed that about SJF scheduling, that is non-preemptive SJF scheduling. There we said that preemption means it will stop the execution in the middle. Non-preemptive means it will not stop the execution in the middle, right? So we have seen one example also for non-preemptive scheduling. So today we will see the example for preemptive scheduling. Preemptive means the process can stop the execution in the middle, right? Voluntarily it can stop, or forcefully also it can stop the execution. So as you can see here, one more name is there for this. Okay, that is shortest remaining time first scheduling. That is called as SRTF scheduling. Shortest remaining time first scheduling. So very simple here. Its concept is that in the ready queue, whenever a new process is arriving, its burst time will be compared with the process which is already currently executing, right? If its burst time is less than the currently executing process, then the currently execution process will be stopped in the middle. Okay, voluntarily or forcefully it will be stopped, and CPU will be given to the new arrived process. Why? Because it is having less burst time. So like that its execution will happen. So always when a process arrives, its burst time will be compared with the process which is currently executing. So this concept we can discuss with an example, right? So for example, consider we are having some processes. Okay, we are having four processes: P1, P2, P3 and P4, right? So their bus times, their arrival times also there. So during these times they have arrived in the ready queue. For example, P1 have arrived at the 0th second, P1 has arrived at the first second, P3 has arrived at the second, P4 has arrived at the third second, for example, right? So this is called as arrival time. And also consider their burst time. So as already we have discussed, burst time means this is the execution time. Process requires for execution. This time is called as burst time, right? For example, P1 required 8 seconds, P2 requires 4 seconds, P3 requires 9 seconds, and P4 requires 5 seconds. Okay. Okay. So consider we are having a timeline like this. So at the 0th second, so this is the time it will start at the 0th second. Okay, so at the 0th second, how many processes have arrived in the ready queue? Only one process has arrived, that is P1. So P1 is the only process. Okay, it will start the execution. So let us take a Gantt chart here. So P1, sorry. Right, so it will start the execution at the 0th second, but it will not complete the execution, right? Till first second only it will execute. Why? Because at the first second one more process have arrived. At 0 to 1, one more process have arrived, that is P1 is already there, it is executed till first second. One more process arrived, that is P2, right? Since P1 executed for 1 second, its remaining burst time will be, that is 8 minus 1, that is equal to 7. Why? Because 1 second it has executed, right? So now two processes are there at the first second, P1 and P2. P2 requires time 7 and P2 requires 4 seconds of time. So among these two we have to compare which one is taking the less time. So since P1 taking 7 seconds, P2 taking 4 seconds. We can say P2 is taking less time. So we will start the execution of P2 now. Okay, why? Because it takes less time. So it will also execute till the fourth second only. Sorry, till the second only. Okay, it will execute till the second. Why? Because at the second one more process have arrived. Okay, those are P1, P2, one more process P3 has arrived, right? So this is what our P2 has executed previously for 1 second. So its remaining bus time is 3. Now in the ready queue, okay, at the second we are having 3 processes, P1, P2, P3. Among these 3, which one will execute first? So we have to take which one is having less bus time at this time, at the second. So we can say P1, P2 is there and P3 is also there. P1 takes 7 seconds, P2 takes 3 seconds and P3 is taking 9 seconds. So we will tell that only P2 is taking less time. So P2 will execute for 1 more second, that is till the third second. Right? So consider this is the third second. So why we have stopped? Why? Because at the third second one more process have arrived. So that is P5. Now at the third second how many processes we have? We have P1, P2, P3 as well as P4. 4 processes have arrived. Right? So till the third second P2 has finished for one more bus time, that is its remaining bus time is 2. Right? Okay. Now at the third second we are having 4 processes, P1, P2, P3, P4 also. Right? So which one is taking less time? P1 taking 7 seconds, P2 taking 2 seconds, P3 taking 9 seconds, P4 taking 5 seconds. So we can tell P2 is taking less time and all processes have arrived. So they will not stop until the execution is finished. So P2 will start the execution at the third second and till its remaining time is finished, that is 2 seconds, it will finish the execution. Means it will finish the execution at the fifth second. So P1's what is this? P2's execution is over, right? This is at the fifth second, right? At the fifth second, P2's execution is over. So we have only P1, P3, P4 pending in the list. So which one will do the execution now among P1, P3, P4? P1 requires 7 seconds, P3 requires 9 seconds, P4 requires 5 seconds. So P4 is the smallest one. So P4 will start the execution, right? At the fifth second it will start the execution. So for its remaining bus time, that is 5 seconds, it will finish the execution, right? It started at the fifth second and it is executed for 5 seconds. It will stop the execution at the 10th second. Its execution is over, right? So now this is P4 also over. At the 10th second, how many processes we have? At the 10th second, we have at the 10th second we have P1 execution is over, not over, right? P1 is there and P3 is also there, right? So among these two, which one will execute now? Next. So P1 requires 7 seconds, P3 requires 9 seconds. So P1 will start the execution. Why? Because it is taking less time, that is 7. So it will start at the 10th second. Its remaining time, that is 7 seconds, it will take at the 10th second. Sorry, 10 plus 7, at the 17th second it will finish the execution, right? Now P1 also over. At the 17 second, how many processes are there pending? Right, at the 17 second, P1's execution is over. Only P3 left. Right. So P3 will start the execution at the 17th second. Requires 9 seconds of execution. So when it will finish? It started at the 17th second. Finish the execution at the what time? It will finish the execution at 25th second. Right, it will finish the execution at the 17 plus 9, sorry, at the 26th second it will finish the execution. Right, so this is about the GNAT chart. Now we will calculate the waiting times. Right, so for example, let us consider the processes P1, P2, P3 and P4. Right, coming to their waiting times. So when P1 has started the execution, okay, its last execution was at the 10th second. It has started the last execution, but we will not consider 10 as its waiting time. Why? Because previously 1 second it has executed, so it is 10 minus 1. Last execution started at the 10th second and previously 1 second it has executed. Its waiting time we will tell as 9. Right, and P2, see, P2 has started the execution at the first second, and when it has arrived at the first second only it has arrived, so its waiting time is 0. It is not waiting. At the first second it came in the memory ready queue, and at the same time it is started the execution and never it stopped in the middle, so its waiting time is 0. After that P3, coming to P3, at the 17th second it has started the execution. Right, but 17 is not its waiting time. When it has arrived, we have to check. P3, see, it arrived at the 17th second, so its bus time will be 17 minus 2, that is equal to 15. Okay, after that finally P4, right, it last execution started at the 5th second, and when it has arrived P4, right, it has arrived at the 3rd second, so 5 minus 3, that is 2, equal to 2. So these are the waiting times of P1, P2, P3 and P4. How we will calculate average waiting times? The average waiting times are time equal to 9 plus 0 plus 15 plus 2. Okay, so total number of processes are 4. So this is equal to us totally 15 plus 9, 26 divided 26 by 4. So this is equal to how much? This is equal to 6.5. You can consider seconds or milliseconds. This is the average waiting time in shortest remaining time first scheduling algorithm, also called as preemptive SJF scheduling algorithm. And other algorithms also there, like round robin scheduling and priority scheduling. So regarding this we will discuss in our coming lectures. Kindly stay tuned. Thank you all.